paper 45. Okay, so let's take a look at question number 1. A box of 25 kg is pulled 12 meter up a rough plane inclined at an angle 8 degrees to the horizontal. The box moved up a line of greater slope against a frictional force of 50 Newton. The force pulling the box is parallel to the line of the greater slope. The box starts from rest and has a speed of 2.4 meter per second at the end of 12 meter. Find the work done by the pulling force. So the diagram over here is actually quite simple. We have an 8 degree here, and you are moving the block going up until here, and the distance over here is 12 meter. Okay, so this we are looking for the work done by the pulling force. So over here, this at the beginning, you are at rest, and when you reach over here, your speed has become 2.4 meter per second. So since we are finding the work done, we will be using conservation of energy. Okay, so now we will be having the GPE gain plus the KE gain plus the work done by the resistance is equal to the work done by the pulling force. Okay, so the formula for the GPE gain is mgh. The KE gain is a half m of the v square minus the u square. The work done by the resistance force is a frictional force multiplied by the distance travel, and the work done by the pulling force is the value, is the things. This is the things I need to find. Work done by the pulling force. Okay, so I will write the work done by the pulling force at the left hand side right now. So mgh, m is 25, g is a 10, h is actually 12 sine 8 degree. Okay, so this is the mgh, and then the ke, half of the m v square minus the u square plus the frictional force is 50 Newton multiplied by the distance travel is 12. So over here it's very clear. Just direct press a calculator, then you will get this one as a 1089.52. But we only want the answer in 3 significant figures. So you can write this one as the 1090. Just highlight that this is a 3 significant figure. Done. This will be the answer for the question number 1. Now we move on to the question number 2. For driving a nail into a block of wood causes a hammerhead to drop vertically onto the top of a nail. The mass of the hammerhead is 1.5 kg and the mass of the nail is 0.005 kg. The hammerhead hits the nail with a speed 32 meter per second and remain in contact with the nail after the impact. Part A, calculate the speed in which the combined hammerhead and the nail move immediately after the impact. Give your answer, correct the 3 decimal places. Okay, so over here we will be using conservations of momentum. So this is the mass for the hammer, and the speed is 32 plus the mass of the nail, but at the beginning the nail doesn't move, is a 0, is equals to after the collisions they remain in contact. That means you just take 15 plus the 0.005 multiplied by the v. Okay, so just use your calculator. You can get the v as 31.894 meter per second. Okay, so this is the answer for the number 2A. Move on, we have a number 2B. There is a contact force. There's a constant force. There's a constant force resisting the motions of the magnitude, 25,000 Newton. Find the distance that the nail is driven into the wood. Okay, so that means after the hammer hit the nail, okay, they're together, then the nail actually enter the wood. We want to find the distance, how much. That means this is the speed that we found just now. Then the distance traveled by the nail driven into the wood is until the velocity here becomes 0, or the speed here becomes 0. So what you need to do now is we need to find the accelerations. Okay. So if you resolve the forces vertically, you will be having the mg minus the fr is equal to the ma. So the m is referred as the nail, the hammer plus the nail. G is a 10. The resistance force is given in the question is 25,000. The mass over here is a 15 plus 0.005 multiplied by A. So just use your calculator. You can calculate all this thing and then you can get your accelerations. It actually is a deceleration because the A is a negative 16,601.30. So I will give the answer in more significant figure to make sure my answer is more accurate. Okay, so we will be using this formula. W square is equal to the V square plus 2AS. Okay, so the W is equal to 0. That means it's a 0 square is equal to the V square. V square is the answer in part A. Part A just now the answer is 31.894 plus the A is a negative 16,601.30. This S is a distance travel. So if you press a calculator, then you can get S is equals to the 0, a very small distance only, 0.0306 meter. Okay, so this is the answer for the number 2B. Now move on. We have a question number 3. Travel 4.8 kilometers between two stations, A and B. The train starts from rest at A and accelerate at a constant rate until it reaches the speed of 30 meters per second. It then travel at this constant speed for 30 seconds before decelerating at a constant rate, coming to rest at B. The total time for the journey is 180 seconds. Find the value t, then hence find the distance moved by the train while the traveling at a constant speed 30 meters per second. So this question actually, it will be easier if you can describe them in terms of graph. So I will use a graph to represent them. So this graph actually will give you some marks. So this graph need to draw properly. Okay, so we will be having, at first you are at rest and then you will accelerate at a constant rate until you reach to the speed of 30. Okay, but you didn't mention that how long is the time. We do not know. Okay, we do not know this. Then after that, you travel with this constant speed for t seconds. That means this is a t. Okay, then after that, you decelerate until you come to rest again. And the total time you know is 180 seconds. Okay, so over here, maybe I draw like this. This is a 180 second. This is the time t. This is the v. So this graph, make sure you draw properly. So over here, we given the total distance travel is equals to the 8.4 km, which means it's 8,400 meter. Okay, so that means the total area is the same as a 480. So this is the trapezium. How to find the total area for trapezium is a half times the 180 plus t multiplied by 30. That will give you 4,800. So just press a calculator, and then you can see that you will get 180 plus t is equals to the 4800 divided by 15. And then simplify further, you can see that your t is 140. So we found the t. But we still need to find something else. We need to find the distance travel at a constant speed. That means we want to find the area here. Okay. So we want to find the areas over here. Then distance. Travel. In stage 2. This is the stage 2. This is the stage 1. This is the stage 2. This is the stage 3. Okay. So since you have a diagram provided, so your explanations, it will be easier. Just say stage 1, stage 2. The examiner will understand. So the distance traveled by stage 2 is actually 30 multiplied by t, the area. So it's a 30 multiplied by 140, and you get 4,200 meter. Done. This will be the answer for the number 3. Move on, we have a question number 4. Planar forces of magnitude 70 Newton, 51 Newton, 34 Newton act at a point O in the direction shown in the diagram. Tangent alpha is 15 over 8. Find the magnitude and the directions of the resultant force, resultant of the 3 forces over here. So over here, I think first of all, we will write down the tangent alpha is equal to the 15 over 8. And we will build a right angle triangle here. This is a 15, this is the 8, and you will get a 17 over here. Then I will redraw again my diagram to indicate vertical and horizontal. This is the alpha, this is the 34, this is the alpha, this is the 51, and this is the 90 degree. So which means that this must be alpha. Okay, so this is a 17 Newton. Now if I resolve the forces vertically, I have a Fy is equal to the 51 sine alpha minus the 17 cos alpha minus, okay, sorry, I need to squeeze everything inside one sentence. So it will be Fy is equal to the 51 sine alpha minus the 34 sine alpha minus the 17 cos alpha. So 51 minus 34, you actually get 17 sine alpha. 17 sine alpha from the right angle triangle diagram. Sine alpha is a 15 over 17 minus the 17 cos alpha. Cos alpha is 8 over 17. So over here, your Fy is a 15 minus 8 is a 7. Then if you resolve the forces horizontally, you get the Fx is equals to the 51 cos alpha plus the 34 cos alpha minus the 17 sine alpha. So you will get this one as a 85 cos alpha is a 8 over 17 minus a 17 sine alpha is a 15 over 17. Press the calculator, you get this one as 25. So the resultant force, the vertical component is 7 Newton and the horizontal is 25 Newton. So your resultant force F is equals to the Fx squared plus Fy squared. That will be square root of 7 squared plus 25 squared. You will get square root of 674, or you can give me the answer in decimal. That will be 26.0 Newton. 3 significant figure. So to find the angle, arctangent. To find the directions is arctangent of Fy over Fx. So it will be the arctangent of the 7 over 25. You will get this one as the 15.6 degree. So therefore, the directions of the resultant force is equal to the 15.6 degree. You measure from positive x axis or x directions. So this is the answer for the question number 4A. So number 4B, move on. The force of magnitude 51 Newton has been replaced by the Pn, acting in the same directions. The resultant of the three forces now act in the positive x directions. So now we need to replace the diagram over here. This one I replace it with P Newton. This one still remain the same. This one still remain as the 17 Newton. This is still alpha. This is still alpha. This is a 34 Newton. This is a 17 Newton. Now they say that the resultant force is only positive x direction. That means at the end, you only have the answer like this. This is your fx. Means the fy is equal to 0. Okay, that is the meaning of it. Okay. So given the resultant force act in positive x directions, actually you do not need to write this because only 2 marks, no need to tell the story. Okay, so we know that the Fy will be equal to 0. So Fy equal to 0, if you resolve the forces vertically, you have a P sine alpha equals to the 34 sine alpha plus the 17. By the way, this is the alpha. Okay. So you will be having the P sine alpha is 15 over 7, 17. 34, this one is a 15 over 17. Then this one is a 8 over 17. So if you simplify it, press a calculator, you will get this one as the 43.1. 3 significant figure. Okay, so this will be the answer for the question number 4B. Now move on, we have a question number 5. car of mass 1,500 kg is traveling on a straight horizontal road, it is given that there is a constant resistant motion to the resistant to the motions. The engines of the car is working at 24 kilowatt, while the car is traveling at a constant speed of 32 meter per second. And the power is now increased to 28 kilowatt. Find the accelerations of the car at the instant when the speed is traveling at 36 meter per second. Okay, so we will need to calculate the formula. If you travel horizontally, you have a driving force minus the resistance force is equal to the MA. Okay, so given the V is equal to 32, your P is 24,000. Okay, and the A is equal to 0 because of constant speed. Okay, this is what the questions give you just now. So you change the FD into the P over V minus the FR is equal to 0. So your P will be 24,000. V is 32 minus the FR. So therefore you can find your resistance force 750 Newton. So now when your accelerations is 36, when the P is equal to the 28,000 watt, your accelerations has become not accelerations. We want to find accelerations. Your speed has become 36. So again, your P over V minus the FR, this time it will equal to the MA. P is a 28,000. Your V is a 36 minus the resistance force. They mentioned the resistance force is fixed, is constant, so it will be remain 750 Newton. The mass is 1,500. Accelerations you do not know. And just press the calculator, you can get your answer. A is 1 over 54 meter per second square. Or you can give the answer in decimal. It will be 0.0185. Okay. Now we are done for the part A. Okay, part A done already. Now we want to move to part B. It is given instead that the resistance of the motion of the car is given as 300 plus 4V. And when the speed of the car is V meter per second, when the engine is working at 20,000 watts and the car is traveling at a constant speed, find this constant speed. Okay, so it's also given when the P is equal to 20,000, your A is equals to 0 because of constant speed. And your V, you do not know. Your FR will be the 340 plus 4V. Okay, this is what they give you. So if you resolve the forces horizontally, you get the P over V minus the FR is equal to the MA. So, you don't need to write MA, just write 0 will do. So your P will be 20,000 divided by V minus the 340 plus the 4V equal to 0. Multiply everyone by V. You will get 20,000 minus the 340V minus the 4V squared equal to 0. Divide everyone by 4. So you will get this one as the V squared. plus the 85B minus the 5,000 is equal to 0. So you can factorize it. Okay, so therefore your V is equal to the 40. Your V equal to negative 125. You should recheck it. So done. This is the answer for the question number 5. Number 5B. Yes, correct. Number 5B. So now we move on with the question number 6. Straight line starting from O at the time t second after leaving O, and the velocity is v meter per second of B is given as V equal to the 15 minus 2t square. Find the values of t when the B is 100 meter per second. So when the V is equal to the 100, so you get 100 is equal to the 15 minus a 2t square. You will get 15 minus 2t equal to the positive negative of 10. So you get a 15 minus 2t is equal to 10, or the 15 minus 2t equal to the negative 10. Over here, you will get t is equal to the 5 over 2. Over here, you will get t is equal to the 25 over 2. We are looking for the values. So these are the two possible values. Okay, done for the part A. Now part B. We want to show that there is a particle of t, a particular value of t for which the velocity and accelerations of the particle are both 0. Okay, we already have velocity as 15 minus 2t square. Now, the dv dt. Using the chain rule, then you will get this. So you will get this as negative 4, 15 minus 2t. So you just say that when the A is equal to 0, negative 4 of 15 minus 2t is a 0. That will give you t equal to the 15 over 2. Then at when the t equal to the 15 over 2, what happened to your v? Your v will be the 15 minus a 2t. You will get 0 as well. Okay. So therefore, A equal to the V equal to 0. We actually prefer to write A equal to 0 and V equal to 0 when the t is equals to the 15 over 2 second. Okay, so now we move on to the part C. Okay, so for part C, we want to find the displacement of B from O at the time that the velocity and the accelerations of the particle are both 0. Okay, so we need to find displacement. Displacement is to integrate the V, which is 15 minus 2t square. Then you integrate this, you will get 15 minus 2t cubed over 3 and then negative 2 plus c. Then you can rewrite it as a negative 1 over 6. Then when the d equal to 0, s is equal to 0. So 0 is equal to the negative 1 over 6, 15 cubed plus c. Okay, so therefore you get the c is equal to the 562.5. Okay, then just put it back. It's negative 1 over 6, 15 minus 2t, power 3, plus the 562.5. And now we want to change the t to become 15 over 2. Then s is equals to the 0 plus 562.5. That will be equal to the 562.5. Done. This will be the answer for the question number 6C. Moving on, we have number 7. We have a particle A is a 6.5 kg, B is a mkg respectively, are connected by a light inextensible string passes over a smooth pulley. The pulley is fixed at the top of a rough slope, which is at an angle alpha to the horizontal, where the tangent alpha is 15 over 12. A is on the rough slope and B hangs below the pulley. The coefficient of frictions between the slope and the A is 0.4. Given that the system is in equilibrium, find the set of possible values of M. Okay, set of possible values of M. So what we need to do now is we start from the easiest one at B. If you resolve it vertically, you can see that the B is hanging. So you have a mg is equal to T, or we just write T is equal to mg. Okay, then at A, if you resolve perpendicular to the plane, at A, I want to find the normal contact. Okay, so you will get R is equal to the 6.5 G. 6.5 G, this is the alpha. Okay, so it's cos alpha. Oh, by the way, I forgot to write down this. I can build the right angle triangle. 5, 12, and then 13. Okay, so over here, you can get this one as a 65 multiplied by 12 over 13, and you get the R is equal to the 60 Newton. Then FR is equal to the mu R. That will give you 24 Newton. Okay. Now we are looking for the resolve the forces still at A. I want to resolve the forces going up the plane. So if I going up the plane, so maybe this one we just say that this is the case 1. Okay, so if at A I resolve the forces going up, that means I actually assume A is going up. Assume A is going up. So if I assume A is going up, then I will get something like this. I will get the T. Okay. If you're going up, then your frictional force will be going down. Your frictional force will work against you. That means you will get T is equal to the mg sine alpha plus the frictional force. So the M is 65, mg is 65. Sine alpha is 5 over 13 plus the FR. Then you can find the T, 49. Okay, you will get this. Oh, by the way, The D is mg, yeah. I forgot. D is mg. So we can write this one as mg. Or maybe we write 10m over here. Okay, so from here, you press a calculator, you have a 49 divided by 10, 4.9. Okay, that is the case 1. Case 2. So just now is a case that the A is going up. So we need to consider the case at A. I also going this way. But this time you have a D plus the FR is equal to the mg sine alpha. Because this round, we will be considering the particle A is going down. If it's going down, then your frictional force will be the same direction as the D. Okay, so it will be D plus FR is equal to the mg sine alpha. D, you know, is a 10m. FR, you know, is a 24. So the mg is a 65. Sine alpha is a 5 over 13. So you press the calculator, you can get this one as the 1 over 10. Or you can give me the answer in decimal. Done. This will be the answer for number 7A. So now we move on with the 7B. It is given that instead the m is a 12, the particle released from rest with the string tucked. Use the energy method to find the speed of the particle when each particle has moved 0.6 meter. You may assume that this occurs before the A reaches the pulley and before the B reaches the ground. So over here, maybe we can redraw again the diagram. Okay, we try to redraw again the diagram. So you're moving at first is like this. This is the B. Oh, I forgot one more thing. So sorry. The question mentioned that is a set of the possible values of m. Set of possible values of m. That means we need to write that the m is actually between 0.1 to 4.9. That is the answer. Okay, so we move on. Now the m can be 12. It's still within the range that we mentioned just now. So the B is going from here to here. So this one is the 0.6 meter. Then the A over here is going 0.6 meter as well. But the distance, the height, the vertical height that you travel is, I call it h. Okay, and we know that this is alpha. So from here, we know the h over 0.6 is equal to the sine alpha. The sine alpha, you can refer to the value here, this triangle. So the sine alpha is 5 over 13. So h is equal to the 0.6 multiply 5 over 13. Okay, so if you press a calculator, I think I will leave it into the fraction form. Okay, I prefer to do it that way. Okay, we found the h. Then we can use the conservations of energy. Okay, so you can see that this case, the B is going downward. That means the GPE for the particle B is lost. But the A is going upward. That means the PGE for the particle A is gain. Okay, so you have to be careful. So right here, we will just say that the GPE, okay, for the A is gain plus the KE also gain plus the work done by the resistant is equals to the GPE at B loss. This is the formula. What is the formula for GPE gain? It will be the MAG H plus the half MA plus MB B square minus a 0 square plus the work done by the resistant. Work done by the resistant, your frictional force, just now we have calculated, is 24. Multiply 0.6. This will be the MB, G, and 0.6. Okay, this is what we have. Okay, so now we want to replace the MA. MA is a 6.5. G is a 10. Your height is this height, sorry. This height is not H. Sorry, correct. The height is H. This height is H. So the H is 3/13 plus the half of the MA plus MB. MA is M is 12. MA is 6.5. Okay, maybe I write, since I write MA in the front. So 6.5 here plus 12. V square, you do not know. Okay, then this one is the 14.4 is equals to the MB MGH. Okay, something like that. So now we simplify them one by one. For the MGH, for the particle A, it will be 15 over here. This one, it will give you 9.25 square plus the 14.4 is equals to the 72. So just use your calculator, you can get your V square is actually equal to the 42.6 divided by 9.25. You can give the answer in fractional form. I think there's no need. So we just straight away press the calculator. That means your V is equal to the 2.15 meter per second. Done. Just like that. This is a 3 significant figure. So this is the answer for the question number 7, B. And this will be the last question for this paper. So I stop the video here. I will see you next time. Bye-bye.